important that you understand them, you know how to apply them, and you know when to apply them. Now, I'll put a pause on all those theorems. Remember, also, we looked at the cases whereby the same theorems fails us. So what we're going to look at now is the last aspect whereby once we are done with it, then we will then be able to solve a differential equation. Let us take a simple case of this differential equation where we started. We consider this differential equation. Which pen am I going to use? Let me take that one. This one, right. Okay, fine. So let us assume we have let that is too big. Right. Let us have this differential equation. Let dy over dx with a in front plus what? Plus b of y be equal to 0 be a differential equation. Be a differential equation. Now, mostly this differential equation, when you look at it, it's linear. Linear DE. But it's linear DE, we say it's a homogeneous linear differential equation. I don't want to explain myself there. So if we take that, we'll try and solve it. So let me have it here. A dy over dx plus b of y equal to 0. To solve this one, I'll separate variables. Let me separate variables. A dy over dx is equal to minus b of y. Right? But now if I were to separate variables, I'll cross multiply by dx. A dy is equals to minus b y of what? Of dx. But now y, we don't need y this side. We divide by y. While dividing by y, we divide by a at the same time. A and b are constant. Therefore, dy over what? Over y is equals to minus b over a what? Dx. Right? Next, I do what? I integrate by direct. In other words, the integral of dy over y is equals to minus b over a integral dx, because b and a are constant. What is the integral of dy over y? Is nothing else but it is ln of y is equals to minus b over a integral of dx. It's x plus what? Plus some constant c. Right? As easy as that. Next. Next, I'll get rid of a log. Getting rid of a log, this will mean that my y is a to the power minus b over a of x plus what? Plus c. And we have seen that before. That is y is equals to a minus b over a. If I to split that times a to the power c, as before. Now, this e to the power c is a constant to some constant. I call it a to the power minus b over a. So that's the solution. But let me write this in a different format. I don't want this index minus b over a. Let be any number m, b minus b over a. Therefore, y is a to the power, sorry, there's x here. There's x there, sorry. I omitted x there. There's x there again. There's x. So in other words, This is a solution. It's a solution that comes from this differential equation. I'll call it is equation 1 here. I'll call it equation 1. Now, let us suppose, good people, let us suppose that this differential equation, this solution to this differential equation is also a solution to some differential equation. So that solution there, y is equal to ae to the power mx, is a solution to the given differential equation. Let us take an assumption. We assume that perhaps that differential equation is also a solution of a differential equation of much higher order than the one that we are given. All what I'm trying to say here, we create a proposition and we say, let the dE now be. Let a dE of higher order, let's say it's a what? D squared y over dx squared plus b dy over dx plus what? Plus cy equal to 0. We call this one is a dE of the second order. Mind you, our first one was a dE of the first order. Now, it's an extension of the first differential equation. Now, let us take an assumption. We assume that this solution here, 1, the one that I call it solution 1, is also a solution to this differential equation. It doesn't make sense as I'm saying it right now, but you'll see that it makes sense at the end of the day. So we assume that y equal to this value is also a solution or is satisfied by this differential equation. All what it means, good people, is that if you solve a quadratic equation, you expect to get at least 2 values. And those values, when you substitute them to the given equation, the answer is also the original one. In other words, the answer is 0. So in other words, if we were to substitute this one into this differential equation, we must obtain 0. But now, before we can substitute, so we substitute what? Equation 1 in what? I will call this one in equation Roman figure 2. I'll substitute that one in Roman figure 2. But now in Roman figure 2, there is the second derivative and the first derivative. All what I have from 1 is just y. So before I do that, what is dy over dx from equation 1? What is the derivative of that? The derivative of that is given by derivative of that one here. First derivative is what? Is a what? A to the power, sorry, yes, sorry. It's a to the power mx. If I will differentiate Roman figure 1, so I call it from 1. Right? Also, in my equation that I will substitute with is the second derivative. I differentiate this one twice. Also, what? What is dy squared over dx squared? In other words, I repeat the same process from here. I will get what? Another a, but I'll get another a coming down from there. So it's am squared, what? A to the power mx. Therefore, let us do the substitution. Therefore, if I substitute, therefore, in Roman figure 2, then what are going to get? A into, there is a second derivative, which is a me, that one squared, close, is my second derivative, plus b, first derivative, is a to the power mx, plus what? Plus c of y. Y is what we are given, is a wait, what is happening with my pen now? a to the power mx equal to 0. We'll try and solve that. Let's try and solve it. If you try and solve that, you can see that there's a common factor here. There's a common factor of what? Of a, of what? Of a e to the power mx. A to the power mx is common. What are we left with here? We are left with a m squared. What are we left with there? Plus what? Plus b m. What are we left in the last one? We are left with c, close that, equals to 0. Solve. A to the power mx is equal to 0. We know that there's nothing that will get out of that when we solve for n, because when we take the log of naught, that will be undefined. So the only solution is on me squared plus bm plus what? Plus c equals to 0. Equal to 0. So what are we coming up with now? It's a quadratic equation. It's a quadratic equation. So that is equal to 0. And that is a quadratic equation. So what does this tell us? It tells us that the y value, the one that was a solution to Roman figure 1 is also a solution to Roman figure 2, because it gives us 0. The only thing that we don't know are my m values. So what are we saying here? We are saying that since, therefore, y equals to ae mx is a solution of Roman figure 2. If we are to extend Roman figure 2 again and extend it to the next order, which is order 3, you will see that y will also be the solution of that. Even of order 4, even of the nth order, that y equal to ae to the power mx will always behave. So now we have a situation whereby we started with just a single solution to a differential equation of order 1, which was equal to y equal to ae to the power mx. But when we extend our thinking and reasoning, we create a supposition whereby we said, what if we increase the order of a differential equation? Is this y value going to help us to get other solution? Now you see that at that equation there, the y equal to ae to the power mx is also a solution of the second order differential equation. At this point in time, good people, I may as well tell you that even the third order differential equation, that's why we'll satisfy that. Even the fourth one, even the fifth one. But because we end up with a we end up with a quadratic equation, so there will be 2 values coming out of that one, of this differential equation. This being the first one. The second one will be y equals to what? B e to the power mx, because when you solve a quadratic equation, you'll get 2 roots. You'll get 2 roots here. By roots, I mean the values of x or m here. Therefore, combining these, you combine them. You combine the solution will be what? A e to the power mx plus what? Plus b e to the power mx, where b and a are nothing else but constant. If it was of the third order, we're going to add plus c e to the power mx. If it is of the fourth order, etc., in that fashion. So good people, what are we saying precisely? We are saying that the quadratic equation that we ended up getting because of the beauty of us having to use y is equal to ae to the power mx, it gives us 2 values of 2 solutions. One is ae to the power mx, the one that we started with, and the other one is be mx. And when we combine those, that is the general solution. So we give this quadratic equation a special name. So we say, we call what? Am squared plus what? Plus bm plus c equal to 0, a what? An auxiliary equation. This is called an auxiliary is an auxiliary equation. So your auxiliary equation is your M equation. And y equals to a e to the power mx plus b e to the power mx is called a complementary function. Complementary what? Function is called the complementary function. So these are our two basic things that we are going to talk about now. You'll see the theory behind it is not that important. What is important is the Aux equation, how to create that, and from it, how to obtain that. Remember, why do we have this last part? Because when we solve for m, just think of this m as x. When you solve for x in this quadratic equation, you will end up with two values. One, perhaps it's 1, the other one is that. So when you combine those, these are the solutions that come out from what? From that second order differential equation. Next, but now is not enough. Remember, if you are given a quadratic equation function to be sketched, you can sketch a function whereby perhaps there are no x values, there are no x-intercept. In other words, the graph does not touch the x-axis. You can sketch it whereby there are two x values. So in other words, m will determine the nature of roots of the complementary function. Let me say here, note m, which is the root of Aux equation, will determine the nature of what? Of complementary function. I'll use CF for complementary function. So in other words, if we know the roots of the quadratic equation there, those roots will determine the nature of the complement function. Now let us take different cases whereby our m values will actually take. So let us take the following cases. Nature of roots of m. Nature of roots of m. Kusho sithi na ukuthi m kungenzeka u-m abe ukuthi uma ukuthi what is our complementary function going to look like? If m is like this, what is our CF function going to look like? We take the first case, case 1. Roots are real and different. Roots, they are real and different. Different, it means not the same. Roots are real and different. Which roots? Roots of a m squared plus b m plus what? Plus c. If the roots are real and different, just think of a case whereby, e.g., let's take a quadratic equation. We have got x squared plus what? Plus 5x plus 6 equal to 0. When you solve here, the roots are x is what? It's minus 3 or what? Or x is what? It's minus 2. That is the meaning of m here. In other words, the roots are real and different. They are not the same. What will that graph look like if I were to sketch that? The graph of x squared plus 5x plus 6. It passes through the x-axis minus 2 and what? And minus 3. This is the graph. Wait, this is the graph. We have here minus 3 here, and we have here minus 2. It will be turning somewhere here, and then that will be the graph. The graph will look like this one. And we touch y-axis there. So this one is x there, that's what, that's y there. So these are my m roots. Remove x by m. So m is minus 3 or m is minus 2. What is y going to look like? Therefore, my y, which I called the complementary function, is given by, my y is given by an unknown a, e, I know my m now. It means here, my m1 is what? It's minus 3, or my m2, it's minus 2. I'm combining those. So in other words, it's minus 3x. It doesn't matter which one I start with, plus the next one, plus b a to the power what? To the power minus 2x. When do we have that? If the roots are real or and different. So that is the case that we have. In other words, if you can write it in terms of m, my m is what? My first m is minus 3, my second m is minus 2. That is the case whereby the roots are real and different. Let's take case 2. We are looking at all the possibilities of m that it can assume or it can take. If roots are what? Are real, yes, equal, ayalingana, but opposite signs. That's another case, opposite signs. So the roots are real, equal, but with opposite signs. What is that case? That case will be this case when we have been solving quadratic. X squared minus 4 is equal to 0. Solve for x. That is x squared is what? Is 4. That is what is x. X is plus or minus 2. The roots are equal. The roots are equal. They are all equal to 2. But one is positive, the other is negative. So if you were to sketch that graph there, if you were to sketch that graph, it will be this graph. It will be this graph. There is a 2 there. There is a minus 2 there. It opens upward. It turns at minus 4 there. That will be the graph. That is the graph. The roots, they are all identical, but they are on opposite side of x. What is my auxiliary equation, my complementary equation going to look like? Is going to be, therefore, my YCF will be equals to, my YCF will be equals to A minus 2x plus what? Plus B, A positive what? Positive 2x. Or another solution there that you can use is y is equals to P cosh of what? Cosh of 2x plus what? Q of what? Of shine what? Of shine 2x. I think you do have this in your calculator. So it's either you have that or you have that. You can use any of your choice. That is if the roots are real but with opposite signs. Let's look at the third case. Case 3. Roots real and equal. The roots now are real and what? And equal. Don't panic. You'll see when we try and solve problem, this will be very easy, but it's a matter of understanding what we are doing right now. The roots are real and equal. What is that? Let us take this case. I can use m or x. Let's take the case of x squared minus what? Minus 4x plus what? Plus 4. Yes, equals to 0. If you solve this, this becomes x minus 2 factors into x minus 2 equal to 0. If you like, is x minus 2 all squared equal to 0. You can see that the roots are what? Are real and they are all equal. That is here, x is equal to what? Positive 2, but how many times? This is being repeated. This is twice because it's x minus 2 into x minus 2. What is the nature of our complementary function? A graph similar to this one will be this one. Will be this graph. So there is my 2 here. So it's this graph. Is that graph. This is your axis of symmetry there. So that's your x there. That's your y there. So the roots are what? They are real and equal in all respect. What is our YCF? Our YCF complementary function is a what? What? 2x plus, be careful here. Then it is also obvious that we can show that the other factor will be bx a to the power 2x. This is very important, good people. Look at that x, how it drops down there. is important here, this one. So with this x here, having those two the same, that tells us that the roots are real and they are equal. Very important. Next, the last one. The last possible case is case number 4. Roots, what? Are not real. Roots complex. That is, are non-real. Remember, non-real. Now, we can use complex numbers. Remember, your z is x plus yj. So all of a sudden there, we are complex there. So remember, if you like, you can also write it as alpha plus or minus beta j. It was derived for us. So the formula that we will use there for roots real and, for roots non-real, it will be a graph similar to this one. Y is equals to what? Perhaps I've been saying, say x squared. Sorry, let us wait for this. X squared. What is happening with my pen now? Right. So we say here, so x squared. My pen is refusing now. Why? Okay. Okay. So let's say the equation is x squared plus 5x plus 1 equal to 0. If I remember very well, there are no roots here. That will be b squared minus that 4 ac 25. Perhaps we make this to be 9, whatever the case might be. So in this case here, the graph will be a graph that opens upwards. I'm not sure where it lies, but something like that. In other words, it's a case whereby there are no x values here. So that is why we are saying the roots are what? The roots are imaginary. What will be your complement function look like? Your complement function will look like YCF is equals to a to the power alpha of x into what? A cos beta of x plus b sine what? Sine beta of x. Where do I get this beta and alphas? So this alpha here is that alpha there, then beta is this beta here. So in other words, the general format, if the roots are complex, will be given by that. That is all what we need, good people. I'll give you examples based on what I've just said here. We'll see how easy it is. Where do we start? We start from here. So let us try and work out this one. An example. Examples. Examples. Examples, solve the following. Solve the following DE. That is d squared y over dx squared plus 4 dy over dx plus what? Plus 3y equal to 0. Remember my Ox equation. I'll take you back to that. Remember my Ox equation. Remember my Ox equation. Now, the example that I've just given you is this of the second order. Is a differential equation of the second order. Is this differential equation? What did I do here? I assumed that that was a solution to that. But now, given the practical example now, I'm not going to go from scratch and have all this nonsense here. All what I will do will be the following. Because out of that nonsense there, I end up with an Ox equation. Sorry. Now from here, I create the Ox equation. Now, you say my Ox equation will be, is the M equation. You remember that was d squared, so we ended up with m squared. There was a here because there was a here, but now there is 1 here. So it's m squared plus 4m plus what? Plus 3 equal to 0. That is what we get. Then solve. Factors here, m plus what? Plus 3 into what? Into m plus 1 equals to 0. That is what is m. M is minus 1, or m is what? It's minus 3. What type of roots are these? Are these roots real? Yes. Minus 1 and minus 3 are real. Are they equal? No, they are different. So the roots are real and different. So what form is it going to take? YCF, complementary function. YCF is a, from what we know, a to the power what? Minus 1 of x, that is that x, plus what? Wait, when? Why is it moving now? Take note. No. What is happening now? This must stay put. Good people, what is it now that is happening? Yeah. Okay, let me see.
Sayazi,
Huh?
I attended. There's another class.
You want me to stop here?
I'm not saying stop, but I'm just letting you know, Guti. There's only 20, how many? 27 people about corner. Because
27 people.
Yeah, was it? Because
Okay.
class as we speak.
Let me just finish up this one then.
Okay.
Yeah. Plus the next one is going to be b a to the power minus 3x. Let me give you the next one. Example 2. Example 2 will be this equation. D squared y over dx squared plus what? 7 dy over dx plus 12y equal to 0. As low sinkanta kakhulu, we form an OGS equation. We form an OGS equation. What is our OGS equation? It's m squared plus what? Plus 7m plus what? Plus 12 equal to 0. Solve for m. M plus what? Plus 3 into what? Into m plus 4 equals to 0. And what are those roots? That gives us what?
M equals to -3.
M is equal to -3, or what? Or m equals to -4. What is your YCF? Your YCF format is A. Are the roots real? Yes. Are they equal? Not equal. So a to the power minus 3x plus what? B, a to the power minus 4x. Then we are done. But when you look at the story behind here, we substituted, we took the second derivative, but we don't need it in practice. We only find the OGS equation and then your YCF. Okay, let me stop here. I'll continue on Wednesday.
Sir.
Yes.
Ngiqalele lelinye class, then I only came to this one. Can I please find out what topic what we're doing today?
Yeah, yes, you will find them. Now everything is settled. You will find it right now. After I'm done here, you'll check on your Teams. It will be there.
Oh, okay. Thank you.
Okay. Now tell others that they need not panic, because on Monday, on Wednesday, I'll start from scratch. But tell them that I want everyone to attend. You will tell me the exact time where to meet you. Is it 4 or 5:05? You will say.
Okay.
We'll communicate.
No problem.
Okay, thank you very much, good people. Thanks.